What happened? Yeah, cool, so it's working. Now let's look at our next question, our question number 2. Okay, so the question number 2 tells us that the cube root of 343 is 7, and is asking us how much larger is the cube root of 343.2. And it says that we should estimate this using linear approximation and round answer to 5 decimal places. Okay, so let's do that. So here's our second question. Here's our second question. The information given is that the cube root of 343 is 7, and it's asking us for the cube root of 343.2. So let's do this using linear approximation. So it's calculus, and we need to find a function. Let's use the function, or I guess we have to use a function, the square root of, or the cube root of x. So yeah, this is our function, and in order to find the linear approximation, we need to use the formula, and the formula of linear approximation is, let's just write in another color, because this is like kind of the knowledge we have, or the preliminary knowledge that we need to know in order to solve this question. So L of x is equals to f of x plus, or I guess we should write it as f of a, because it's linear approximation, where a is just the point that we want to use to approximate, or the y-coordinates of the point that we want to use to give the linear approximation. Okay, so this is our formula. So the first step is to find the first derivative of the function f of x, because we need to use the function f of the derivative of the function right over here. So we know that the function cube root of x can also be written as in this form, and in order to find the derivative, we just minus the power by 1. So 1 over 3 minus 1 is negative 2 over 3, and we pull the power up to the front of the function. So this is how we this is the derivative of f of x. And now we have the derivative of f of x. Let's find the let's find f of a. So the point we want to use to approximate this value is 7. So, or I'm sorry, the point that I want to use to approximate this value, or the point A, is 343, but we know f of a is, or let's just write it down. So a is equal to 343, and f of a, or f of 343, is equals to the cube root of 343, which we already know, given the question, the cube root of 343, it's 7. So this would equals to 7. Okay, so we already have the value f of a, and we now need to find the value f prime of a. So f prime of a is equals to 1 over 3, or I guess I should just write a, I should just plug the value of a, because a is 343, written right over here, and we'll just do 1 over 3, x, which is 343, which is a, and to the power of negative 2 over 3. We know, or I guess we need to find this value. Can we just directly find this value? Let me see. So we can also write it in this form. No, we can't directly find this value. It's too hard. Let's just use a calculator then. So we have 343, the power of negative 2 over 3. Okay, so this is our f prime of f prime of a. So now we just use the equation. We have L of x, which is the x we want to approximate. It's 343.2. So let's write it over here. X equals 343.2, And out of 343.2 is equals to f of a, which we already know is 7, right over here, it's 7, plus f prime of a, we know is 1 over 3 times 343 to the power of negative 2/3. And that expression is multiplied by x, which is 343.2, minus a, which is 343. So we would find the answer of the linear approximation. We know that it's 1 over 3 times 343 to the power of negative 2/3 times 0.2. And that's our linear approximation. Now let's just try to plug it in the calculator to see what the actual value of that linear approximation is, because the question asks us to round the answer to 5 decimal places. Okay, so let's see. So we want to find 7 plus 1 over 3, or 1 over 3 times 343 to the power of negative 2/3 times 0.2. Oh, whoopsie. And our answer would be 10.26666. Let's just write it down. I can't find, I just dropped my pen. Where did my pen go? Oh shoot. Huh, that's odd. I can't find my pen anymore. Oh well, but I can have the answer. Okay, so the answer is, my pen is here. So the answer is just 10, and we want to round it to 5 decimal places, which is an odd request in my opinion. So the answer would just be 10.2666, 1, 2, 3, 4, and 5, because 6 is larger than 5, so we round it up. So yeah, this is our answer of the linear approximation. And then it also, but it doesn't ask us the value of the linear approximation. It asks us how much larger is the cube root of 343.2. So we need to find the cube root of 343. So we need to find the difference minus the cube root of 343.2, which is, or I guess need to go the other way around, because the cube root of 343.2 would be larger than the cube root of 343, because 343.2 is larger than 343. So yeah, that will be our value here. 10.26667 minus 7, which would just be 3.26667. Whew, that was a long question, but that will be our answer of the difference between the cube root of 343 and 343.2 using linear approximation. So this is our result. Alright, let's look at our sample solution here. So they also use a function f of x equals to cube root of x. I mean, you have to use that function. And then they find the derivative of 343, or they find the value of f of a first, and they found the derivative of 343, or the derivative of f of x, and they try to find the derivative, or f prime of x of a, which is probably correct. I'm not 100% sure, and then use linear approximation. But right over here, they said that the value of f prime of a is 1 over 143 over here, but then they changed it to 1 over 147, which is not correct, I don't think. So let's see. So let's see over here. 1 over 3 times R1 over 3 times, oh shoot, I think our calculation is wrong, because the 3 is supposed to be up on top instead of at the bottom, because it's multiplied. Oopsie. Okay, negative 2 over 3. And let's fix, you know what, let's fix our answer first, and then let's fix their answer. Okay, so our value for f of a, the only thing that changed is our value for f of a. Let's do draw, and then let's do a little eraser. So yeah, that kind of tells us the importance of using a calculator. I'm not really good at using calculators, as you could see. Yeah, we actually don't need to change anything except the final result and the result of this expression over here. Okay, because our expression over here is correct. We just did it wrong while we are typing into the calculator. So we know the value of L of 343.2 is actually 7.00136. Well, that makes more sense that they're asking us to give 5 decimal places. So we just swap it over here as well, and we know the difference is actually 0.00136, which makes sense because linear approximation is quite good in this case, and the difference is quite small. Now let's look at their problem. Okay, now our final result is the same, but their problem here doesn't make sense because their values have changed between 1 over 143 to 1 over 147. Okay, so how do we verify that? Let's just use our calculator to verify that, or verify the result. So it's negative 2 over 3, and then they said 1 over 143, or 1 over 143, and 1 over 147. Into over 3. Okay, so the value of our term f prime of a is actually 1 over 147, not 1 over 143. So their fourth line is incorrect, but they made their changes over here, so their final result is correct. Cool. Okay, so their final result is correct, but the fourth line is incorrect. Okay, and we'll just say solution, the final solution is correct, but you need to get the steps right, or else it's kind of confusing and it doesn't quite make sense because you had incorrect steps and then you had the correct solution, which is odd. Okay, let's just say solution is incorrect. And over here, now we're moving on to our third.